Hello everyone, welcome to our YouTube channel Mathematics with Ahsan. In this video, we'll talk about how to find if a function is even, odd, or neither. I will teach you a very easy way. So let's get started. A function is even if f of minus x is equal to f of x. So a function is even if there is no change occur after changing sign of x. Then a function is odd if f of minus x is equal to minus f of x. So a function is odd if by changing sign of x, the sign of all values will change. If sign of all values not change, then the given function is not odd. Now a function is neither even nor odd if f of negative of x is not equal to f of x or negative f of x. It means if we change the sign of x, then the sign of some values of the function will change but not completely. Then it's neither even nor odd. Now let's move to the example. For example, f of x is equal to x square. If here we put negative x, then f of negative of x is equal to negative x square is equal to x square, which is equal to actual function. So f of negative of x is equal to f of x. We can write this. So it's an even function. Now let's take another example. For example, f of x is equal to x cube. If we here put negative x, then f of negative of x is equal to negative x cube, which is equal to negative x cube, and it is equal to negative f of x. So it's an odd function. Another example is f of x is equal to x plus 1. Here we put negative x, then f of negative x is equal to negative x plus 1. So here it is not equal to actual function or negative f of x. So it's neither even nor odd function. Here one thing is important. The names even and odd come from the powers of x. Like if y is an even power of x, as in y is equal to x square or y is equal to x4, it's an even function of x because even power remains the sign unchanged. And similarly, if y is an odd power of x, as in y is equal to x or y is equal to x cube, it's an odd function of x because odd powers change the sign of all terms of x. Here are some more examples for you. Like in a function f of x is equal to 5x square plus 9x8. It's an even function. And the next one is g of x is equal to 4x 5 plus 3x. It's an odd function. And the next one is h of x is equal to 2x cube plus 9. It's neither even nor odd function. So if even and odd powers are coming together or a constant appear with only odd powers of x, then the function becomes neither even nor odd. It's a formula. So simply if even powers are appears, so the function will be even, and if odd powers will appear, then function will be odd, and if the combination of both even and odd powers appears, so it's neither even nor odd function. Here I have a question for you, and question is, a constant function is even, odd, or neither? Give the answer in the comment box. So let's talk about with respect to graphs, that how can you found from a graph that the given graph is a graph of even odd function. So the graph of an even function is always symmetric about the y-axis. It means a reflection across the y-axis leaves the graph unchanged. In simple words, if we rotate the graph of function at 180 degree with respect to y-axis and the graph becomes actual, so it's a graph of even function always. For example, as you know, f of x is equal to x square is an even function, and you can see the graph of it. If we rotate this graph at 180 degree with respect to y-axis, the graph remains the same, and the even functions are always symmetric about the y-axis. Now, what's the procedure for odd function? So the graph of an odd function is always symmetric about the origin. Equivalently, a graph is symmetric about the origin if a rotation of 180 degree about the origin leaves the graph unchanged. For example, as you know, f of x is equal to x cube is an odd function, and you can see the graph of it. And if we rotate the graph at 180 degree with respect to origin, so graph remains unchanged. So in this way you can find how from the graph that the given graph is a graph of a even function or odd function. Now let's move to the conclusion. Please carefully read the below passage. It's the complete summary of today's topic. Hope so you read it.